Another command that I want to show you on this switch is related to the link between switch 1 and switch 3. And that interface, let's first of all look at show interface F0 slash let's first look at show interface G0 slash 1 switch port. And we notice here that gig 0 slash 1 is operationally a static access port. Let's take a look at gig 0 slash 2. We can see that that port is operationally a static access port. We could do a show interface trunk command, and right now we don't have any trunks that are configured. So all of my interfaces in this case on switch 1, they're all access ports. Now, let's go ahead and go into global config mode and let's create a VLAN. Let's create VLAN 10 and we'll name this VLAN 10. And let's end. And now let's do a show VLAN. And now from our output here, we can see that VLAN 10 was created and it is active. And right now it's not assigned to any interfaces. Now, how do we get VLAN 10, if we were to assign a port on switch 1 into VLAN 10, how do we get that port to communicate across to switch 3 in VLAN 10? Well, we know that has to be done with our trunking configuration. So here's what we're going to do. We're going to go into config T, we're going to go into interface F0 slash 1, and we're going to give it the switch port access VLAN 10 command. So now if I do a show interface status, I can see that FA0 slash 1 is now connected, but it's in VLAN 10. And you can see all my other interfaces are connected in VLAN 1. So right now I don't have any trunks and we're not going to be communicating across any links here if you're in VLAN 10. Now I'm going to come over here into, let's just look at this again. My connectivity on gig 0 slash 2 over to switch 3. So let's go into interface gig 0 slash 2. And let's do switch port trunk encapsulation .1q. It's not required here because that's the only type of trunking encapsulation that it does. Now some switches you're going to have to issue that command. Now here then I'll do a switch port mode trunk. And let's type end. And now we can see the interface changed state to down and then it went back up. Now let's do a show interface status, pipe include trunk, and there we go. Gig 0 slash 2 is now a trunk interface. Now if I did the show interface trunk command, now we get a little bit of a different output. Gig 0 slash 2, the mode is on, the encapsulation is .1q, we are trunking, and the native VLAN is 1. Now you'll also notice that on port gig 0 slash 2, the VLANs that are allowed in the active management domain are VLANs 1 and 10. So now let's just move over here to switch 3. Now switch 3 should have negotiated dynamically that interface as a trunk. So let's do a show CDP neighbor, and our connectivity to switch 1 in this case is on gig 0 slash 1. So show interface trunk should now show me that gig 0 slash 1, the mode C here is auto, and the encapsulation is .1q, the status is that we're trunking, and the native VLAN is 1. Now an important thing to point out here is that the mode is set to auto, and that is why these interfaces did not dynamically trunk to begin with. You have the ability to enable trunking as being on, which we did on switch 1, which forced this trunk to come up. You can also be set to auto or desirable. Now auto is very passive. It sits back and it waits until the other side says, hey, let's trunk. Now if both sides are set to auto, then neither one of them are going to negotiate the trunk. If one side were set to desirable and one side were set to auto, then they would negotiate because the desirable side is active. And we'll illustrate that in just a moment between switch 1 and switch 2. But for now, we can leave that to auto, or we could statically make gig 0 slash 1 a trunk port. I'm not going to do that just because the trunk is up and I don't need to mess around with it right now. And I want you to see the differences here in the output. But what I also want you to notice here is where it says VLANs allowed and active in the management domain. And right now it says gig 0/1 has VLAN 1. Where's VLAN 10? So that's where that VTP protocol that we looked at comes in. We don't have VLAN consistency right now because we don't have our VTP domain set up. And because our VTP domain is not set up, that would mean that we would have to configure VLAN 10 statically on this switch. Now, you'll notice when I create VLAN 10 here, and I name it VLAN 10, and I do a show VLAN brief, you can see here I have VLAN 10 now, and it is showing up as being named VLAN 10, and now that's not consistent with what switch 1 shows. See, so we have a little bit of a consistency issue. We want to make sure that we have VLAN consistency, because otherwise, when we do our show interface trunk, now we see VLAN 1 and 10 being allowed across that trunk. But if I were to create another VLAN here, like say VLAN 11, VLAN 12, and VLAN 13, and I show VLAN brief, I see those new VLANs here on switch 3, but if I move back to switch 1, I don't see those VLANs. So you see, that's a problem when we don't have consistency with our VLAN databases. Let's go ahead and create that consistency first. So let's do a show VTP status. And right now you can see the VTP domain is not defined. But you do see that the VTP operating mode is server, and the maximum number of VLANs that are supported locally is 255, and the number of existing VLANs is 6. And right now we're on a current revision of 1. And we can also see that the MD5 digest is seen there, and that's along the lines of that password that we can set to maintain our consistency. So what I'm going to do is I'm going to create a VTP domain called PS1. So it went from null to PS1. And now let's come on over here and do a show VTP status. So nothing's really changed other than my VTP domain, right? You can see my VTP domain now is PS1, and you can also see that my revision number is still revision number 1. Let's go back over here to switch 3, show VTP status. And the revision number is 1, and notice the number of existing VLANs is 6. You'll notice also he picked up the VTP domain of PS1. So now if I do a show VLAN brief, where did those VLANs go? You'll notice that VLAN 11, 12, and 13 have now disappeared. And see, this is an effect of enabling VTP. This switch here received a VTP update, and he synchronized to it, and now the VLANs are missing. So we got to be real careful with how we enable VTP when we've got existing VLANs in the environment. So this, for the CCIE lab exam, if for some reason you're messing around with VTP and you've got VLANs defined, you could really hose up your connectivity if you're not careful. But understanding some of these basics is kind of nice to see. So let's go ahead and come here, and since we are in VTP operating mode server, we should be able to come in here and add that VLAN 11, VLAN 12, and VLAN 13. We'll hit end, and we'll do a show VTP status now. And you'll notice the revision number is now 4, and there are 9 existing VLANs. Now let's come on back over here to switch 1 and do a show VTP status. And notice we now have 9 VLANs, and we are revision 4. So we're synchronizing. You can see the danger in this if you don't do a password authentication. And that is simply the fact that if a switch were to delete a VLAN that's in server mode, we're in big trouble. So the VLANs start to disappear, and we lose connectivity where it needs to be. Again, going in here, if I were to do a show VLAN brief, there's VLANs 11, 12, and 13, okay, as we expected.